Assalamualaikum and hi to Dr. Nuruzan. Our group today, Group 6 from MTK3401 Advanced Statistics Group 2 will be presenting about multiple linear regression. So here is our group member, Nurul Syuhada binti Muhammad Dagang, Siti Namilah binti Osman, Nurul Ifah binti Ayub, Abdullah Fahim bin Sarafi, and Abdul Hafiz Alim bin Mustafa Kamal. So in order to finish the task, we have divided our work into 4 main sections. So the first section is the discussion part, which involves all group members. The second section is the notes preparation for presentation, which is done by Nurul Syuhada and Nurul Ifah. And the third section is the slide preparation and video editing done by Siti Nabilah. And the fourth section is the presenting part, which is done by myself, Abdullah Fahim, Abdul Hafiz Alim, and Nurul Syuhada. Before that, I will give the definition of multiple linear regression. Multiple regression is a statistical technique that uses several explanatory variables to predict the outcome of a response variable. The goal of multiple linear regression is to express the linear relationship between the explanatory variables and response variable. As example, if there is data which is named as the number of cars and the percentage of air pollution, the number of cars will be the independent variables, and the response variable, the dependent one, will be the percentage of pollution. So the multiple linear regression is used to see how much the both data are relate each other. So here is the multiple linear regression formula. The formula is y equal to b naught plus beta 1 x1 plus the so forth plus beta n xn plus error term. So y is the predicted value of the dependent variable. B naught is the y-intercept, which value of y when all other parameters are set to 0. Next, beta 1 x1 is the regression coefficient of the first independent variable, or maybe we can say the effect that increasing the value of the independent variable has on the predicted y value. And next, beta n xn is the regression coefficient of the last independent variable, and the last one is the error term, which is the model error, or we can say how much variation there is in our estimate of y. So, to calculate the linear regression, there are multiple ways, but in this presentation, we will be using two ways. The first way is least square method, and the second way is Gaussian elimination. So, least square method is a statistical procedure to find the best fit for a set of data points by minimizing the sum of the offset or residual of points from the plotted curve. And the least square regression is used to predict the behavior of dependent variables. Here is the example 1.2.3 from the lecture notes that we are asked to do. So the question look like this. By the method of least square, fit y equal to beta 1 x1 plus beta 2 x2 plus beta 3 x3 to the 5 observed points x1, x2, x3 and y. So here's the point. So the first step of the calculation is you have to construct the table. We construct the table to make our work easier. So on the most left is y followed by x1, x2, x3, x1 square, x2 square, x3 square, x1 times y, x2 times y, x3 times y, x1 times x2, x1 times x3, x2 times x3. So we are going to fill the table accordingly, and we complete the table according to the label on the first row. So when we complete the table, we sum all of the column in the last row. So the next part of the calculation will be presented by Abdul Hafiz.
For the step 2, note that x1 equal to 1 in each point. So we are really fitting y equal to beta 1 x1 plus beta 2 x2 plus beta 3 x3. Since we have 3 independent variables in this equation, therefore we will get 3 normal equations. For the first equation, summation of x1 power of 2 plus summation of x1 times x2 plus summation of x1 times x3 equal to summation of x1 times y. For the second equation, summation of x2 times x1 plus summation of x2 power of 2 plus summation of x2 times x3 equal to summation of x2 times y. The third equation is summation of x3 times x1 plus summation of x3 times x2 plus summation of x3 power of 2 equal to summation of x3 times y. In this equation, we have to make sure that for the first equation, the main variable is x1. Therefore, the position of x1 power of 2 must be in the first. For the second equation, summation of x2 power of 2 must be in the middle because the main variable is x2. For the third equation, the main variable is x3. Therefore, the position of x3 power of 2 must be in the last. So the normal equation that we get is, first is 5 beta 1 plus 6 beta 2 plus 4 beta 3 equal to 16. Second, 6 beta 1 plus 14 beta 2 plus 6 beta 3 equal to 26. Third, 4 beta 1 plus 6 beta 2 plus 10 beta 3 equal to 9. For the step 3, by using simultaneous method, we can generate a new equation for beta 1 and beta 2. First, from equation 1, we will generate a new equation, which is equation 4 for beta 1. Then we will get beta 1 equal to 3.2 minus 1.2 beta 2 minus 1.8 beta 3. Second, substitute equation 4 into equation 1 to generate equation 5 for beta 2. Then we will get beta 2 equal to 1 minus 3 over 17 beta 3. After we get equation 4 and equation 5, we can substitute equation 5 into equation 4 to get the equation 6, which is the simplified for beta 1. Then we will get beta 1 equal to 2 minus 10 over 17 beta 3. Next, we substitute equation 5 and 6 into equation 3 to get the value of beta 3. Then the value is beta 3 equal to negative 85 over 112. Since we have get the value of beta 3, we can substitute it into equation 5 and equation 6 to get the values of beta 1 and beta 2. Therefore, the value is 274 over 112 for beta 1 and 127 over 112 for beta 2. Lastly, the least square fit will be y equal to 274 x1 plus 127 x2 minus 85 x3 over 112. If x1 always equal to 1, then the equation will read y equal to 274 plus 127 x2 minus 85 x3 over 112.
Okay, next, we can use matrix method, which is Gaussian elimination method. Before that, we need to know the normal equation is 5 beta 1 plus 6 beta 2 plus 4 beta 3 is equal to 16. Next, 6 beta 1 plus 14 beta 2 plus 6 beta 3 is equal to 26. And 4 beta 1 plus 4 plus 6 beta 2 plus 10 beta 3 is equal to 9. Firstly, we have to rewrite the system in matrix form. Then we proceed by using the elementary row operation, which for the first matrix we need to change row 1, which row 1 divide by 5. And then we need to change the row 2, which is row 2 minus 6 times row 1, and also we change the row 3 by row 3 minus 4 times row 1. And then next we need to change row 2 by row 2 divided by 6.8. Then we change row 1 by row 1 minus 1.2 times row 2, and also we change row 3 by row 3 minus 1.2 times row 2. And then we proceed by changing row 3, which is we divide the row 3 by 112 over 17. And then we change the row 1 by row 1 minus 10 over 17 times row 3, and also we change row 2 by row 2 minus 3 over 17 times row 3. Therefore, we got the answer beta 1, beta 2 and beta 3, which is beta 1 we got 217 is 274 over 112. Beta 2 we got 127 over 112, and beta 3 we got negative 85 over 112. This the least square fit is y is equal to 274 as 1 plus 127 as 2 minus 85 as 3 over 112. And lastly, if x1 always equals to 1, then the equation reads y is equal to 274 plus 127 as 2 minus 85 as 3 over 112. That's all from me. Thank you.